Hi everyone, and welcome to the first of 3 videos looking at some past paper questions on the topic of ionic bonding. The first question here is asking us what ionic bonding actually is. Lots of things you could say here, but there's only ever one thing that they give you a mark for, and the key thing here is about the bonding. Okay? If we're talking about ionic bonding, why are they actually bonded together? The bonding is the electrostatic attraction. Okay? It's not about the fact that it's a metal and a non-metal. It's not about the fact that we're losing and gaining electrons and not sharing them. Okay, the bonding is the fact that you've got an electrostatic attraction between oppositely charged ions. Okay, then it wants us to draw a dot and cross diagram to show the bonding in magnesium sulfide. We only need to draw the outer electron shells, and that's fairly standard. They don't make you draw everything. So we need to have a look at the periodic table. Magnesium is here in group 2, so therefore it's going to have 2 electrons in its outer shell, and it's going to lose those 2 electrons and end up as a 2+ ion. So my magnesium, I'm going to draw it with no electrons in its outer shell. I could draw it with 8 to show it's gone to the next shell down. That would also be fine, but drawing it with none is also acceptable. I can't be bothered to draw 8, to be honest. And therefore we said if it's lost 2 electrons, it's going to have a 2+ charge. Okay, what about sulfur? Sulfur is in group 6, so it's got 6 in its outer shell, and it's going to gain 2 electrons to get up to 8. Okay, so here's my sulfur. Here are its 6 electrons that it had anyway. Here are the 2 that it's gained from the magnesium, and if it's gained 2 electrons, it's going to have a 2- charge. Okay. Be careful with the charges, it should be 2+ and 2-, not -2 and +2. They might get a bit picky with that. Right, then we have a question here which is saying, we're making potassium chloride. Here's a diagram of the potassium chloride lattice. Add labels to each circle to show the particles present in the lattice. Okay. So if it's an ionic compound, then the particles that are in the lattice are going to be ions. So we need to ask ourselves, what are the ions here? So again, if we look at the periodic table, potassium is in group 1. So it's got 1 in its outer shell. It would lose 1 electron and it would make a K+ ion. So potassium is going to be K+. And therefore, because they're only bonding 1 to 1, chlorine must be just Cl-. And that makes sense because chlorine's here in group 7, so it wants to gain 1 electron. So those are my ions. I just now need to put them into the diagram, and I'm just going to alternate them, because the positive and negatives will attract each other. So if I put K+ here, then next to it I'm going to have Cl-. Next to it I'm going to have Cl-. Next to it this way I'm going to have Cl-. Therefore that one's got to be K+. That's got to be surrounded by Cl-. This one's going to have to be K+, and so is this one. Okay. So you should find you get this alternating pattern. Okay, that's one of the features of an ionic lattice. You get this regular repeating pattern of oppositely charged ions. Finally, last question here. Many ions contain oxygen combined with atoms of other elements. So we have this nitrate 5 ion, which has the formula NO3-. What's the formula of aluminium nitrate? Okay, so this we need to look at aluminium. So on our periodic table, aluminium is in group 3. So it's got 3 electrons in its outer shell. When it reacts, it's going to lose those 3 electrons, and it's going to form an ion with a charge of Al3+. So if I then want to combine these 2 ions to make a compound, I'm going to have 3 nitrate ions, so that I end up with 3 negative charges to balance out the 3+. I'm going to have to write this in a bracket then. We're going to have to say I've got 1 aluminium, and I've got 3 nitrate ions.